Hello, I'm Zach. Today we are going to talk about chapter 6 of Eloquent JavaScript. In this chapter, we will learn more about objects. So, what are objects? The idea of object is like a TV set. All you need to know is how to use the control, the remote, and you don't need to know how it works inside of a TV set. So in object provides you an interface that you can interact with. You can control the object, and it hides the details of the implementation. And this concept is also called encapsulation, which means the implementation is encapsulated and you only know the interface. This idea is very powerful, and many programmers follow it, and many programmers even write everything in objects, and their programs are made of many different objects, and this style is called object-oriented programming. So what's in an object? We have variables and methods in an object, and they are both properties. And if you still remember, methods are just functions within an object. So you can call a method by using the dot notation with the object name and of course the parentheses. And since methods are functions, and functions are actually variables with a function value, so actually there is only one thing in an object that's variable, or you can call it property. So they are basically the same thing. And another thing you need to know is this variable. It's a special variable that points to the object that the function was called on. For example, here we have a speak function, and inside of it we have this doc types. And what does this mean? Let's take a look at the object here. We have a white rabbit, and its type is white, and it has a method called speak, and it's the function speak. So and we have another rabbit called fat rabbit, and the type is fat. So when we call white rabbit dog speak, the type of the white rabbit will be passed to the speak method, because the variable this refer to the object that calls this function. So we have the white rabbit says as a result, and in the fat rabbit we got the type of fat, so we have the fat rabbit says as a result. The call method, we've already seen the apply method of function and the bind method of a function, and we mentioned a little bit about the first argument of these two functions are the this value. And there is another similar method. It's the call method, which allows you to set this value. So for example, the same speak function, we use the call method, and pass in an object with the type property. So we got the old rabbit says. Yep. So we pass this object as this value. Okay. And in apply, it's basically the same thing, but we need to pass in an array as the second argument. Yeah. Prototype. Let's take a look at this example. We have an empty object called empty, and when we log the toString method, we got the function toString as a result, but we didn't create this function in the empty object. How come we have the toString function, and when we run the toString method, we got this as a result. Where is the toString function from? And actually it's from its prototype. All objects are derived from a prototype called Object.prototype. A prototype is another object that is used as a fallback source of properties. Almost all objects have a prototype. So Object.prototype is the final prototype for all objects. So when we pass in, as you can imagine, get prototype of, we'll get the prototype of the argument. So when we pass a empty object to this method, we will get object prototype as a result. That's why we get a true here. And since Object.prototype is the final prototype, it doesn't have a prototype for itself. So when we run get prototype of on Object.prototype, we got null, which means nothing. So every object have their own prototype. So function has function.prototype, arrays have array.prototypes. So here is an example. It's not a number. I hope you still remember this function. It's a function, so when we run object.get prototype of, we got function.prototype. And this is an empty array, so when we run this on it, we got a array.prototype. We can use object.create to create an object from a prototype. So here we have a prototype, and we use object.create with the prototype, and to create this variable will have the function speak. And here we assign a type to this variable and run speak. Yep, you will got this from the prototype. Okay, and constructor. Let's take a look at this example. We have a constructor called rabbits. Pay attention to the R. It's a convention that the first letter of a constructor should be capitalized. So this is a constructor, and when we use the new notation to create a new object or new instance, the constructor will be run and a new instance will be created and assigned to this variable. So here we have a constructor, we have the new notation, and then we create a instance from this constructor and pass it to Killer Rabbit, and Killer Rabbit is an instance of rabbits. And again, Black Rabbit is also an instance of the rabbits. Yep. So constructor will return a prototype for the instance, for the object, and since every object is derived from Object.prototype, so the new prototype is also derived from Object.prototype. So here is an example. We create a speak function, speak method in the prototype, and it will be available for all the instance of that prototypes. So we create a prototype, a speak method in rabbit.prototype, and it will be available for Black Rabbits as well as for the Killer Rabbits here. Yeah, because it's in the prototype. And these are the Black Rabbits and the White Rabbits are instance of this prototype, so they can accept the speak method in the rabbit.prototype. Yeah. One thing I want to mention is the difference between new and Object.create. Basically, new will run the constructor of that object, but Object.create doesn't do that. That's the difference between two of them. Okay. You can override a property derived from the prototype. So, for example, in our Rabbit prototype, we have a teeth property, and then in the Killer Rabbit, we want a different value for the teeth property. So we just assign a new value to it, and you got a new value in Killer Rabbit, and it doesn't affect the prototype, so it doesn't affect the value in Black Rabbit. Yep. And so we can see the toString method is available for array as well as for object, and in the array prototype, toString is overridden. So when you run toString on an array, you will get all the elements printed with a comma in between. And when you do this, do the equal operator on them, they are different. So when you run toString on when you run Object.prototype.toString on an array, you will get something like this: an array with object and array as in it. Yeah. So the toString in Object.prototype is different from toString in array.prototype. So the toString method in the array is overridden. For properties, we have something called enumerable, which means it can be iterated by for-in, something like for-in loop. So all properties that we assign by ourselves are enumerable. So when we do this Object.prototype nonsense and assign a value to the nonsense property, it's enumerable. So you can use for in to get this value, get this property. But all the standard property in Object.prototype are non-enumerable. So toString is not enumerable. So when you run for in, you won't see toString as a result, and we can define a property as non-enumerable using the Object.define Property method. We pass in the object, the prototype we want to define on, and then the property name, and an object within it we define enumerable as false, and the value of the property. So after that, when we run for name in map is an array, and we cancel out everything. We got pizza and touch tree, but we don't have the hidden nonsense which we define here. But when we console log directly the map.hidden hidden nonsense, we got the value high, which we define here, which means hidden nonsense is available in map, but it's not available for iteration. And another useful method is has own property. So you can use this method to check if a property is directly available in an object. So we use this to check toString if map has its own toString. The result is false, which means map doesn't have its own toString, but it probably has the toString method, which is derived from its prototype, like the array.prototype. Yeah, but it's not its own. So when we use has own property, we got a false. Okay, we can create a prototypeless object using object create and passing argument of null, which means nothing. So here is an example. We create a objectless, a prototypeless object called map, and then we assign a property called pizza, an element. And when we console log toString in map, in will check if the toString property is in the object. We got false, which means map doesn't have toString property in it, not even from its prototype, because it doesn't have any prototype. But when we do pizza in map, it's true because it has a property called pizza. Okay, another object-oriented programming concept is polymorphism. That means you have one interface and multiple implementation. So for example, toString, we have toString for Object.prototype, we have toString for function prototype, we have toString for array.prototype. They are all called toString, which means the same interface, but they have different implementation, which means when you run Object.prototype to toString, the result will be different from array.prototype.toString as we have seen just now. And this idea is called polymorphism. Yeah. And another useful method is Object.keys, which will return an array of all the elements in an object. So in this example, we have an object, we have an array with 3 elements. When we run Object.keys on it, we got all the index of the array, and these are all the elements in this array. We can use this index to get all the elements in that array. With this, we can check like how many elements are there or in an object, how many properties are there in an object. Yeah. Getter and setters. The get or set notations allows us to specify a function to be run when the property is read or written. Let's take a look at this example. We have an object called pie, and for the high property, we use get and a function here, and set also for high, the property high, and it takes a value as the argument and then output this line. So when we read the height value, this function will be executed. So it will return the length of the elements. So there are 3 elements in this array, so we got 3. And when we try to set a value to this property, this line will be executed. So, and it will output this line. Ignore attempt to set the height to 100. So whenever you read or write something, the getter and the setter will be executed. You can add getters and setters to an existing object or prototype using Object.define Property. So we pass in the prototype or the object, and then the property we want to define, and then the getter, and it's a function, and here is the body of the function. So whenever someone reads the high property, this function will be executed. It's basically the same as this one, return the length, right? And another concept is called inheritance. It's also an important concept for object-oriented programming. So here is an example. We've already have an object called text cell, and we want another text cell which align the text to the right. They are basically the same thing, except the alignment is different. So here we create an object called R text cell, and inside it we just call the text cells, which means to generate something exactly the same as in text cell, but passing this as this variable, which means you will get the object return will refer this will refer to R text cell rather than text cell. And then we use object create to create a prototype, which is exactly the same as in text cell doc prototype. So they share the same prototype. The only difference is here we override the draw method. So in here we try to align the text to the right. So the R text cells is inherited from text cells, and the only difference between them is the draw method. So, and it's a new object now. You can use the new notation to create a new instance of that object. Yep. So inheritance allows you to build slightly different data types from existing data types with relatively little work. So since our text cell is similar to text cell using inheritance, we don't need to rewrite all the program within text cell. We can just reuse the program within text cells to create a new new data type called our text cells. Okay. Finally, we have the instance of operator. Here are some examples. When we create an instance from our text cells, and it is of course an instance of the our text cell object. And then here we create another our text cell instance, and it is also an instance of the text cell object because our text cells inherited from text cells, so it is also an instance of the text cell. But when we create an instance of the text cell, it is not an instance of our text cell because our text cell inherited from text cell, but text cell does not inherited from our text cell, so it is not an instance of our text cell. So you see the lower level is an instance of the higher level object. And another example, we have an array here, and it is of course an instance of the array object. Yep. Let's review what we have learned today. First, we talk about the object-oriented programming. There are three important concepts for this idea. The first one is encapsulation, which means all you need to know is the interface. You don't need to know the detail and how it is implemented. And the second idea is polymorphism. That means you have one interface, but you have different implementations, like the toString method. Inheritance is very similar to polymorphism. The difference is inheritance focus on data types. You use inheritance to create a new data types. Like in the text cell example, we have an existing data type called text cells, and we need a new text data type called our text cells, and they are very similar. So we inherited everything in text cell and then override some properties or create some new properties, and that's instance. That's inheritance. And then we talk about this variable, which refers to the object which calls the function. And the call method allows you to assign this value. And prototypes. We talk about every object has its own prototype unless you create a objectless, a prototypeless object. So Object.prototype is the prototypes of all objects, and We have also function.prototype for functions, array.prototypes for arrays, and we can use Object.getPrototypeOf to find out what prototype an object is derived from. And we can use Object.create to create a new object from a prototype. And we talk about constructor. Constructor is a function that will be run when you use new to create a new instance of an object. So new notation is used to create a new instance of an object, and then instance is an instance you create with using the new, and it's returned from a constructor. And we have Object.define Property. You can use it to define the numerable setting, or you can use it to set the getter or setter, and has own property, can be used to check if an object has a property directly. Yep. And object keys can be used to get all the elements or the properties in an object. We can create a prototype-less object using Object.create with the new as argument. And getters and setters, you can use the get or set notation to assign a function to a property. When it is read or writes, this function will be executed. And you can use Object.define Property to set a getter or a setter to an existing prototype or object. And finally, we have instanceof method. You can use it to check if a variable is an instance of an object. Yeah. Thanks for watching. Make sure you do the exercise at the end of chapter 6. If you need help, please comment. And the slides of this video is available on my website. Make sure you subscribe for the next chapter. I will see you in the next video. Bye.